Powering Canada Strong. Number 3. We have questions. We have answers. We have questions. When people talk about transmission line losses, what do they mean? Transmission lines are the long-distance power lines that move electricity from region to region. But when electricity travels great distances, some of the power is lost along the way. This is known as line losses. What does that mean? We talked with Randy Stubbings, a retired professional engineer with 45 years of experience in the Alberta electricity industry. We asked him, what are line losses and why do they happen?
Well, transmission losses, basically what happens is if you put 100 units of power in at one end of a transmission line, only 95 units of power come out the other end. The volume of losses on a transmission system depends on a lot of different things, such as the voltage of the grid, the number of substations that are connected to it. The length of the transmission lines is an important factor, and also the technology type. So an alternating current transmission line will have higher losses than a direct current transmission line over a given length of line, but the DC or direct current line will have higher losses at either end because you have to convert from AC to DC, put it down the DC line, and then convert it back to AC because our infrastructure is built on AC or alternating current model. So generally, high voltage DC is economic over very long distances, more economic than AC over very long distances. For transmission in local areas and within large urban areas like the city of Calgary, alternating current makes sense. In Alberta, transmission losses have historically been in the 4 to 5% range. Some systems are higher than that, some are lower than that, but that's really losing it here. That's basically what happens is you get less out than you put in. And the longer the lines, the more your losses are going to be.
What is that a function of? Resistance?
Well, it is a function of what's called resistance. And so a larger conductor will have a smaller resistance and therefore lower losses, but the conductor size, as the conductor gets bigger, it also becomes more expensive. You need larger towers and that kind of thing. So there's always an economic trade-off between building bigger and higher voltage lines, losses, and there are other characteristics of transmission lines, such as maximum power capability, width of right-of-way that you have available, things like that. So it's not just a case of saying, well, we'll build these big transmission lines and everyone will be happy. There's always been an economic balancing act to design the right kind of transmission facility for its purpose. And again, if your purpose is to bring power, say, from Edmonton to Calgary, that's different than if you're moving power around within the city of Calgary.
Read our reports, The True Cost of Wind and Solar Electricity in Alberta. What you really need to know about a renewable energy that the Pembina Institute won't tell you. Clean Electricity Standard, Delusion versus Reality. Watch Net Zero and the Future Power Grid on Friends of Science YouTube channel. Politicians can't stop climate change.